The future of naval warfare is changing faster than ever, and the US Navy FY2026 destroyer concept represents a major leap forward in how modern warships are designed, powered, and armed for the battles of tomorrow. This next-generation naval vessel is not just another upgrade of existing destroyers. It is a complete evolution in maritime combat technology, combining stealth, artificial intelligence, advanced radar systems, hypersonic weapon compatibility, and improved survivability into one highly capable platform. At first glance, the ship immediately stands out because of its sleek and angular profile, carefully engineered to reduce radar detection and minimize its signature across multiple spectrums. Every line on the hull appears purposeful, giving the vessel a futuristic appearance that looks more like something from a science fiction film than a traditional warship. But behind that aggressive design is a serious military machine intended to dominate the seas in an era where threats are becoming more sophisticated and unpredictable. The FY2026 destroyer is expected to serve as a multi-role combat platform capable of handling air defense, anti-ship warfare, anti-submarine missions, missile interception, electronic warfare, and long-range strike operations all at the same time. Modern naval warfare demands flexibility, and this vessel appears built around that exact philosophy. Instead of focusing on a single specialty, the destroyer acts as a floating command center that can coordinate with aircraft carriers, submarines, drones, satellites, and allied fleets simultaneously. One of the most impressive aspects is the advanced integrated combat system that allows the ship to process massive amounts of battlefield information in real time. Using artificial intelligence and automated threat analysis, the destroyer can identify incoming missiles, enemy aircraft, or hostile ships within seconds and respond faster than human operators alone ever could. Power generation is another area where this destroyer pushes the boundaries. Traditional naval ships rely heavily on mechanical propulsion systems, but the FY2026 design is expected to feature a highly advanced integrated electric propulsion system. This setup not only improves fuel efficiency but also provides the enormous electrical power needed for next-generation weapons and sensors. That becomes especially important when discussing directed energy weapons such as high-energy lasers. The US Navy has been investing heavily in laser technology, and this destroyer may become one of the first frontline warships fully capable of operating powerful laser defense systems against drones, missiles, and small attack boats. Unlike conventional missiles, lasers can engage threats at the speed of light and potentially reduce operational costs because they do not require expensive interceptors for every attack. Another major highlight is the ship's radar and sensor package. The destroyer is expected to carry some of the most advanced radar arrays ever installed on a naval vessel. These systems can track hundreds of targets simultaneously across massive distances, providing early warning against aircraft, ballistic missiles, and even stealth threats. The radar integration works together with space-based assets and airborne surveillance platforms, creating a fully connected battlefield network. In practical terms, this means the destroyer can see threats before those threats even realize they have been detected. Situational awareness is one of the most important advantages in modern warfare, and this ship appears designed to maximize that advantage at every possible level. The missile systems onboard are equally impressive. The destroyer will likely use advanced vertical launch systems capable of firing a wide range of weapons from the same launch cells. These can include long-range surface-to-air missiles, anti-ship cruise missiles, land attack missiles, and potentially even hypersonic weapons in the future. Hypersonic missiles are especially important because they travel at extreme speeds while maneuvering unpredictably, making them incredibly difficult to intercept. By integrating hypersonic capability, the FY2026 destroyer could strike enemy targets from vast distances with devastating precision. This dramatically expands the strategic reach of the vessel and makes it a critical asset in high-intensity conflicts. Anti-submarine warfare remains another core mission of the destroyer, especially as underwater threats continue to grow globally. The ship is expected to carry advanced sonar systems, unmanned underwater vehicles, and anti-submarine helicopters capable of hunting enemy submarines across large ocean areas. Modern submarines are quieter and more dangerous than ever before, so detecting them requires extremely sensitive equipment and rapid data analysis. The destroyer's combination of onboard sonar, airborne sensors, and AI-assisted tracking could make it one of the most effective submarine hunters in the world. This is especially valuable for protecting aircraft carrier groups and critical maritime trade routes. The ship's stealth characteristics deserve special attention because they influence almost every aspect of the design. Traditional destroyers often feature exposed antennas, large radar reflective surfaces, and visible weapon systems. In contrast, the FY2026 destroyer integrates many of these components into the structure itself. Angled surfaces deflect radar waves away from enemy sensors, while heat reduction technologies help minimize infrared detection. Even noise reduction systems are expected to play a role in lowering the vessel's acoustic signature underwater. The goal is not complete invisibility but rather reducing the enemy's ability to detect, track, and target the ship effectively. Crew efficiency is another area where the Navy appears to be making significant improvements. Older destroyers require large crews to operate and maintain complex systems, but automation aboard the FY2026 vessel is expected to reduce manpower requirements substantially. Smart maintenance systems can monitor equipment health continuously, detecting potential failures before they become serious problems. Automated ammunition handling, advanced damage control systems, and AI-assisted operations could reduce crew workload while improving overall readiness. Fewer sailors on board also means more space for mission equipment, improved living conditions, and potentially lower operational costs over the lifespan of the ship. One fascinating feature of the FY2026 destroyer is its expected ability to operate alongside unmanned systems. Naval warfare is increasingly moving toward drone integration, and this vessel appears designed for that future. The ship could deploy aerial drones for reconnaissance missions, surface drones for patrol operations, and underwater drones for mine detection or submarine tracking. These unmanned systems effectively extend the destroyer's reach far beyond the horizon, allowing it to gather intelligence and engage threats without placing human crews directly in danger. This networked warfare approach gives commanders far more flexibility in both offensive and defensive operations. The survivability of the vessel is another key selling point. Modern anti-ship missiles are extremely dangerous, and naval combat environments are becoming more lethal every year. To survive in such conditions, the destroyer incorporates multiple layers of defense. Long-range missile interceptors provide the first shield against incoming threats, while medium-range systems and close-in weapons handle anything that gets closer. Electronic warfare systems can jam enemy sensors and confuse incoming missiles, while decoys create false targets to divert attacks away from the ship. Combined with stealth technology and rapid response automation, these defensive layers significantly improve the ship's chances of surviving in combat. From a design perspective, the destroyer balances aggression with practicality. The hull form is optimized not only for stealth but also for stability and efficiency during long deployments. The bow cuts through rough seas effectively, while advanced stabilization systems help maintain operational performance even in difficult weather conditions. This matters because naval vessels must remain mission-ready across a wide range of environments, from calm oceans to storm-heavy waters. The ability to maintain high combat effectiveness regardless of sea conditions gives the destroyer a major operational advantage. Another interesting aspect is the command and control capability of the vessel. In many ways, the FY2026 destroyer acts as a mobile battlefield headquarters. Advanced communication systems allow seamless coordination with allied forces across air, sea, land,